Question 2, here we have the speed time graph showing us the path of a the speed of a skydiver as they fall out of a hot air balloon. We don't really care about the height yet, but we're told that after 30 seconds she opens her parachute. So for part A, when it says label with an X the point where she opens her parachute, that should be pretty straightforward if you bother to read the question, because it literally tells you when she did that. So at 30 seconds we're going to draw a little X, and you'll notice that the graph does have a very radical change happening at that point, which makes sense because she's falling on her own, just gravity and friction keeping her up, or just keeping her flying, and she flies constantly, and then suddenly she has a very large drag force introduced from the parachute, and that's why the graph changes so dramatically. But the question is not asking us about that yet, it's just asking us to identify. If you didn't read the question, you still can answer this based on the shape of the graph, but it is literally in the instructions. Then for the second part of A, we want to label Y and Z as the two parts where she has a terminal velocity. Terminal velocity we know is constant. And on a speed time graph, that means that I'm at the same speed value the whole way, so it just looks like a horizontal line. So that's these two sections here. Oh, not an X, we want a Y and a Z. And for part B, this is a little bit of a more difficult questions because we have to describe, right? So we're not calculating anything, we're just using our words. Specifically, we want to talk about the forces acting on the skydiver, and we want to talk about her motion. So is she moving quickly, slowly, accelerating, decelerating? Those are the words we want to use. And then for this part here, when it says forces acting, we want to make sure we talk about the forces that are present at every point, specifically over the first 30 or so seconds, because we want to know from the start until her parachute opens. So with regards to forces, she's got her weight or gravity going downward, and she's got friction or air resistance going upward, and together there is a resultant downward force for the first 10 seconds, but then after 10 seconds there is no resultant force, and hence our constant speed, because the air resistance gets really big when you go really fast, and eventually the two forces are the same size. And 10 seconds meaning like up to here, right? That's where we start to flatten out. So the latter 20 seconds, it is constant because there's no resultant force, but the first 10 seconds there is. Now we want to talk about her motion. We haven't done that yet. So during the first 10 seconds, when there is a resultant downward force, there is a downward acceleration. So that's the part that refers to the motion rather than just the forces. But then after 10 seconds, when there is no resultant force, there is no acceleration, only constant speed. / terminal velocity. So that's where your marks come from. 2 marks come from discussing forces in the first 10 seconds and forces in the last 20 seconds, as well as talking about how those forces actually affect the motion. So it's making that link, right? Each of these force discussions has a tie to the motion. So when we're talking about the first 10 seconds, Here we have our forces. Here we have talk about the resultant. We have talk about when it happened and what the movement looks like during that time, which is the acceleration. And then for the second bit, when we have no resultant force, we say that it comes from the fact that the air resistance has increased, and we've also talked about not just when it happens, the force is happening, but how she's moving, which is no acceleration and constant speed. And then for part C, we need to find the average speed in the first 4 seconds. So the first 4 seconds are right here. Average speed, essentially we need to average out our maximum and our initial and our final speeds. Or we can find the area under the graph, which is my displacement, and the time over which it happened, and then find the average speed using that. So first method, essentially the same thing, but first method would be 40 meters per second minus 0 meters per second divided by, plus, because we're taking an average, plus 2 gives me an average of about 20 meters per second. Or I can just find the displacement, which is the area under the graph, this area right here. It's a triangle, so that is 1/2 height times width, which is 10 seconds, which still lands me at wrong unit, because this is displacement, just meters. So if that's how far I'm going and it takes me 10 seconds, my average speed, distance over time, 200 meters divided by 10 seconds. Either way, I end up with an average speed of 20 meters per second. Either method works. Marks come from showing the calculation that you're using and from the actual answer.